Welcome to this video. Is about Cambridge International AS and A-Level Probability and Statistics 1, October-November 2020, paper 52. Question number 1. A fair six-sided dice with numbers 1, 2, 3, 4, 5 are thrown repeatedly until 4 is obtained. Find the probability that the 4 requires fewer than 6 throws. Fewer than 6 throws will be 1 minus p to the power of n, whereas n value is nothing but how much? Over here it is going to be 5, because fewer than 6 throws will be 5. 1 minus p to the power of n, so it is 1 minus 5 upon 6 whole to the power of 5. Why it is 5 upon 6? Probability of getting what is this p4 is 1 upon 6, and not getting 4 will be nothing but what? 5 upon 6. So 1 minus p to the power of n, so where n is going to be 6 less than 6 throws, which is nothing but what? 5. On another occasion, a die is thrown 10 times. Find the probability that a 4 is obtained at least 3 times. So, out of 10 times, 3 times, 10C3. P is obtained 3 times. So, what am I going to do? Is at least 3 times, means 10C3 plus 10C4 plus 10C5 plus 10C6 and so on, which is very difficult to add. So, 1 minus 10C0 minus 10C1 minus 10C2. If I do, I'll be getting the same answer. So, and what is over here? 10C0 will be 1 by 6 whole to the power of 0 and 5 by 6 whole to the power of 10. Then 1 by 6 whole to the power of 1 and 5 by 6 whole to the power of 9. 1 upon 6 whole to the power of 2 and 5 upon 6 whole to the power of 8. So it becomes 1 minus 0.1615056 minus 0.3230111 minus 0.290710. Simplify that, 0.225. Next, question number 2. A bag contains 5 red balls and 3 blue balls. S takes 3 balls at random from a bag without replacement. It is without replacement. The x variable represents number of the red balls that she takes. Show that the probability that she takes exactly one red ball is going to be how much. So if the first one is a red ball, second one should not be a red ball, and the third one is not a red ball. So first one is a red ball will be 5 upon 8. Second one is not a red ball will be 3 upon 7, because one is decreased. And third one is not a red ball will be 2 upon 6. But this can be repeated in 3 times. So because it can be no red, red and no red, or no red, no red and red. So it can be 3 times. So therefore simplify that, you should be getting 15 by 56. Draw the probability distribution table for X. So I'm drawing the probability distribution for X. So this is X. Then how many red balls can be there? 0 red balls, 1 red ball, 2 red balls and 3 red balls. So it can be 0, 1, 2, 3 red balls, X, and probability of capital X equals to small x. Now what we got? We got as, just now we got 1 red ball is nothing but what? 15 upon 16. So I can fill it up over here, 15 upon 16. Now I want for 0 red balls. 0 red balls means, what should I do for the 0 red balls? First one is not a red ball, second one is not a red ball, and third one is not a red ball. So it is nothing but what? 3 upon 8, 2 upon 7, and 1 upon 6. So which is going to be 1 upon 56. Then I will be trying for 3 red balls. Probability of 3 red balls. So first one is a red, and second one is a red, and third one is a red. So it's going to be 5 upon 8 times 4 upon 7 times 3 upon 6. So which is going to be nothing but how much? 10 upon 56. subtract all from 1. 1 minus 1 upon 56 minus 15 upon 56 minus 10 upon 56. We will be giving you the answer as 15 or 30 upon 56. So this is 56, 15, 1 upon 56, then minus 15 upon 56 minus 10 upon 56. When you do that, you should be able to get this. This is 25, 26, 26. So 30 upon 56. This is going to the probability distribution table. Given that expected value is this much, find the variance of x. So how do I find it out? Variance of x. Variance of x equals to 0 square times 1 upon 56 plus 1 square times 15 upon 56 plus 2 square times 30 upon 56 plus 3 square times 10 upon 56, then minus mean square. Mean was 15 upon 8 whole square. Simplify that, you should be getting 225 by 448. Question number 3. PR runs 2 kilometers every day and her times is normally distributed with mean 10.1 and standard deviation 1.3. Find the probability that on a randomly chosen day PR takes longer than 11.3 to run the 2 kilometers race. Probability of x greater than 11.3. Convert into z greater than 11.3 minus 10.1 by 1.3. Probability of z greater than 0.9231, which is 1 minus probability of z less than 0.9231, 1 minus 0.822, which is 0.178. Of 75% of days, PR takes longer than t minutes to run the 2 kilometers. Find the value of t. So probability of x greater than t equals to 75%. So probability of x less than t will be equals to 25%. So probability of z less than t minus 10.1 by 1.3 equals to 0.25. But this 0.25 is not there in the table. Whenever it is not there in the table, subtract from 1, 0.75 and swap this. So what does it becomes? Probability of z less than 10.1 minus t by 1.3 is 0.75. So 10.1 minus t by 1.3 equals to 0.674. So 10.1 minus t equals to 1.3 times 0.674. So from here, I will be getting the value of t as 9.22. On how many days in a period of 90 days would you expect that PR take between 8.9 to 11.3 minutes to run 2 kilometers? So probability of x lies between 8.9 and 11.3. So 10.1. 10.1 means it should be, if at all the mean is 10.1, over here it is 11.3 and over here it is 8.9. You can see this gap is nothing but what, 2.2. This gap is also 2.2. So it is equally distributed on this one. So what am I going to do that? How can I find it out from the normal distribution? We know that it is less than, greater than 11.3 was 0.178. So this part is going to be 0.178. 0.178. So over here, because of symmetry, this part also will be equal to 0.178. Now we know that the total part is going to be nothing but how much? 1. So if I do 1 minus 2 times of 0.178 will be giving me the answer for the between part. Between part, if at all I want, I have to do 1 minus 2 times of 0.178, which is going to be the answer as 0.644. Question number 4. In a certain country, the weather each day is classified as fine or rainy. The probability that a fine day is followed by a rainy day is 0.75. But we haven't completed the previous one, that's the probability, but it is for 90 days. So what am I going to do? Number of days. Don't forget that one. So number of days equals to 90 times 0.644, which is going to be 57 days. Next, the probability that a fine day is followed by a fine day is 0.75. Fine day is followed by a fine day is 0.75. Probability that a rainy day is followed by a fine day is 0.4. So this is 0.4. Then the probability that it is fine is 0.8. If it is fine is 0.8, so not fine will be 0.2. So this has to be 0.25 and this has to be 0.6. Find the probability that 2nd April is fine. 2nd April is fine means it should be fine and rainy and fine. So it can be 0.8 times 0.75 plus 0.2 times 0.4, which is going to be 0.68. Next, X is an event that April 1 is fine. Y is an event that April 3 is rainy. Find the value of X intersection Y. X intersection Y. Probability of X, which is nothing but what April 1 is fine. And Y, April 3 is rainy. So, what is he asking us to find it out? He is asking us to find probability of X intersection Y. So, what should I be doing it out for that? So, let me erase this part. Now, it is fine and X is it April 3 that and Y is an event that April 3 is April 3 is rainy. April 1 is fine and April 3 here 3rd April. 3rd April is rainy. Is rainy. So over here it has to be rainy. So over here rainy and this is fine. So 0.25 and 0.75. So it has to be for rainy means nothing but what it should be 0.8 times 0.75 times 0.25. And for this also we are going to do that one. For April 3 it is fine and rainy. Fine and rainy. So rainy is followed here 0.4, 0.6. So what are the going the ways? 0.8 times 0.275 times 0.25. So where April 1 is fine and April 3 is rainy, or another way of checking it out, the same thing is nothing but what 0.8 times 0.25 times this one in both the ways. 2nd April is of no use, so 2nd April it can be fine or rainy, but 3rd April it has to be rainy. So therefore it's going to be 0.8 times 0.75 times 0.25 plus 0.8 times 0.25 times 0.6, which is going to be 0.15 plus 0.12, which is 0.27. Find the probability that April 1 is fine given that April 3 is rainy. So, probability that April 3 is rainy. April 3 can be rainy, so it can be this rainy also. 0.2 times 0.4 times 0.25, or it can be either this rainy too. 0.2 times 0.6 times 0.6. So it can be either both the ways. So over here 0.75, 0.25, 0.4 and 0.6. So totally April 3 is rainy will be, this is Y, which is April 3 is rainy, is, we got it, 0.8 times 0.75 times 0.25 plus 0.8 times 0.25 times 0.6. Then apart from that, there are another two new options for rainy, plus 0.2 times 0.4 times 0.25 plus again 0.2 times 0.6 times 0.6, which is going to be 0.362. So what is he asking? Probability of x given y, which is probability of x intersection y divided by probability of y. Probability of y is 0.362. What is x but nothing but what? He's asking over here, in this case, he's asking that it is that April 10 is fine. What will be the April 10 is fine? April 1 is fine, not April 10. April 1 is fine was this one, 0.27. 0.27, which is going to be 0.746. Question number 5. The following table gives the weekly snowfall in centimeters. Represent the information on a stem and leaf diagram. So, this is Dados and this is Linva. So I'm writing it out, the stems 0, 1, 2, 3, 4. Then the leaves will be 6 and 8, 0, 0, 2, 5, 6. Then it should be 2, 8, and it should be 6, and it will be 2. Now for this side, it should be going to be written as 0, 2, 9, 0, 1, 2, 5, 6. Then it is 2, 6, and it is 0. Don't forget to write the key. Key will be 6/3/2. I can take any number, means 36 centimeters in Dados, whereas 32 centimeters in Linva. This is going to be the answer. Find the median and the interquartile range of the weekly snowfall in Dados. So how many people are there basically? How many notings are there? 11 weeks. So for Q2, 11 plus 1 by 2, 12 by 2, sixth term. So what is the sixth term? 15. So I have the sixth term over here, 5 terms on left side, 5 terms on the right side. Then the middle of this one, 5 plus 1 by 2, 3 by 6 by 2, third term. Third term is going to be Q3, which is 28. Similarly over here, 5 plus 1 by 2, which is third term after the median. So it's going to be nothing but what? Q1, this is Q3, and whereas this is Q1. Question number 5b. Find the median. So how many terms were there? 11 terms were there. 11 terms. So for calculating Q2, 11 plus 1 by 2, 12 by 2, which is sixth term. So what will be the sixth term? Sixth term is going to be 15. Now I have sixth term over here. So there are 5 terms on the left side and 5 terms on the right side. So the middle term for this one is 5 plus 1 by 2, sixth term means third term. Third term is going to be my Q1, which is 10 centimeters. Then again over here also 5 plus 1 by 2, 6 by 2, which is third term. Third term from sixth term, which is going to be the Q3, which is 28. So IQR equals to 28 minus 10, which is 18 centimeters. The median, lower quartile and upper quartile of the weekly snowfall in Linva at 12, 9 and 32 respectively. Use this information to compare the central tendency and the spread of the weekly for that one. So we can see that we will be writing all the values. For Davos, it is least number is 6 and highest number is 42. Minimum, maximum, Q1, Q2, and Q3. This is 6 and maximum is 42. Then this is 0 and 40. 42, 0 and 40. This is for Davos and this is for Linva. Q1. Q1 is 10, 15, 28. 10, 15, 28. Then after getting Q1, what is being asked there? Then we have to find the comparison. So we can see that what is happening in Davos, Q1 and Q2 and Q3, we have to write it out, right? So for Linva, we have already written as 10, 15, and 28. For Q1, this is Q1 is 10, 15, and 28. 10, 15, and 28. That is for Linva. That is for Davos. So for Linva is, let me write it out over here. It's going to be 12, 9, 32. 12, 12, 9, 32. So what we can say that in Linva it is more. What is this? 32. The maximum is 32. Amount of snowfall in Linva varies more than that of this one, because over here the gap, you can see that from median lower quartile. So this is the one they are changed. This is 12 and this is 9. You can see that the gap between median and Q3 is much more, 20, whereas over here it is only 13. So therefore amount of snowfall in Linva varies more than Davos. That is 1 mark. Another mark is going to be nothing but what? On average, snowfall in Davos is higher. Question number 6. Mr. and Mrs. Ahmed, along with their children, two children, Mr. and Mrs. So, in Ahmed and Ahmed wives and two children, children 1, children 2. Mr. and Mrs. Baker, B and B. So they have three children, children 1, children 2, children 3. Are visiting an outdoor activity center together. They will divide into groups for some of the activities. In how many ways this 9 people can be divided into a group of 6 and 3. So first of all, I choose 9C6, and from the remaining 3 I choose 3C3, which is going to be 84. 5 out of 9 people are selected at random in a particular activity. Find the probability that this 5 people contains all 3 of Baker's children. They should be containing all 3. So 1, 2, 3, 4, 5. So over here children 1, children 2, children 3 is gone. So what is left over? Only 2 more people I have to left over. From 5 it is 4 and 5. 4 and 5. Already 3 has been selected. 3 has been selected over there. So I have to select 2 more. I have to select 2 more. And how many am I left over with? Nothing but what? I am left over with 6 people. So 6C2. Now the probability. Probability means favorable is 6C2 by total number of ways. What is total number of ways? There are 9 people and I have to select it out 5, 9C5. Simplify that, 0.119. All 9 people stand in a line. Find the number of different arrangements on which Mr. Ahmed is not standing to Mr. Baker. So, first of all, we'll take total waste. Total waste is nothing but what? 9 factorial. And if at all we take those two problematic people together, together wills Ahmed and Baker as 1 unit. So remaining 7 units will be there. So totally it is nothing but what? 8 units. 8 factorial divided by, do I need to divide it out? No need to divide. Times 2 this time, because it was A and B, it can be B and A also. Times 2. So 8 factorial times 2, which is 282, 240. So how I got that 282 minus 40? So what do? I got it over here. 9 factorial minus 8 factorial times 2. So it is going to be total minus together 8 factorial times 2. That will be giving you the answer. Find the number of different arrangement in which letter exactly one person between Mr. Ahmed and Mr. Baker. 1, 2, 3, 5, 6. Then it should be 9. 7, 8, 9. Between Ahmed and Baker. So one person is there. So totally how many we have? We have Ahmed's are 3 and Baker's are 5. Ahmed is 3. Where is it? Ahmed and one child. How many children does it Ahmed have? 2 children. 2 children. Children 1, children 2. Baker 3 children. Children 1, children 2, children 3, children 4, children 5. Check that. It is 5. Then in this way, when you can see that this can be done in how many such ways. So now A, B over there, A star B, then again 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 A star B. So totally how many ways it can be done? We can see that it can be done in 7 ways. So 7 ways, 7 times. Remaining how many are left over? What is this? 7 people are left over and 7 places. 7 people in 7 places can be done in nothing but what? 7 factorial. And again, these two AB can also be written as BA. So times 2. So 7 times 7 factorial times 2, which is going to be 70,560. That's going to be the answer. So I think so. There are only 6 questions. This completes the paper. See you in the next paper. Bye.